Hi, I'm George Self. This video is one in a series designed to help with R labs for BASV316 Introductory Methods of Analysis. This is Lab 9, Parametric Hypothesis Testing. A hypothesis is an attempted explanation for some observed phenomena. For example, maybe a physician notices that babies born of women who smoke seem to weigh less than women who do not smoke. Well, that could lead to a hypothesis about smoking and the impact of smoking on a neonatal weight. If the hypothesis involves continuous data, then that would require parametric testing. And in this lab, we'll take a look at the two most commonly used parametric tests. First would be ANOVA. This stands for Analysis of Variance, and it's used when there are more than two groups of samples. So you have three or more populations, three or more samples that you're going to analyze, and the goal is to see if there's any significant difference between those three samples. You can see that the command for ANOVA is fairly simple. When I run this, R will give us back a lot of information. The most important thing, about the only thing we want, is the p-value. Now, I discussed p-value in an earlier lab, but you can see here that the p-value is less than 0.05, so this is significant. And this would tell me that whatever it is we were testing, in this case we were looking at Morley's data concerning the speed of light in the experiment, that there was a significant difference between the various groups in this particular experiment. Now I'm going to copy this, and let's take a look at our guided practice. I'll paste this in. For the guided practice, we want to use the NPK data frame. This is an experiment where we varied the amount of nitrogen, phosphorus, and potassium in a field and looked at the output. So we're going to look at yield when grouped by block. Now, block was the way that the farmer divided up his field. And let's see here. And we see that the ANOVA here was 0.08. That is not less than 0.05. So this particular ANOVA says that this experiment did not yield any kind of significant results. The deliverable, now copy this. The deliverable is actually multiple deliverables. Let me paste this in here. What I want you to do is use the CAFE data frame, and we want to look at lengths. It should be a lowercase l in there, by day. Let me run this. I just want to make sure that much will work all right. It looks like it did. So now I can copy this. We want miles by party size, PTYSIZE. I can copy it in again, and this time I want age by food, and one more time we want tip by service. And what you would enter into your deliverable document, your Word document, would be simply the p-values for each of those ANOVAs. Here's the last one, for example. Tip by service, the p-value there was 0.2077. A similar test that's often used for parametric data are what's called a t-test. A t-test is used whenever there are only two groups that you are comparing instead of more than two. The demonstration, you'll notice the t-test formula is almost exactly like the ANOVA formula. And again, we're looking at a p-value here. This p-value is 0.07, which is larger than 0.05, so this is not a significant result. I will copy that, and let's go down here to the guided practice and paste this in. What we're looking for here is using the NPK data frame again. And I want to test yield when grouped by N. That's the nitrogen test. And when we do this, we see that the p-value is 0.02. That's less than 0.05, so this is significant. I'm going to copy all of this, and here's our deliverable for this part of the lab. We're using the cafe data, and I want to do miles by recommended, RECMD. Copy that. Next is length by preference. That's abbreviated PREF. Next is bill by recommend. And finally is tip by preference. And let me run that. This gives us all of these p-values. Again, all you have to report is just the p-value. And for instance, this last p-value is 9.131 e negative 0.7. That's times 10 to the negative 7th. So this is very significant. That's about it for this lab. It is fairly simple. Good luck with it. If you do get hung up on it, please contact me and I'll be glad to help. I'll be seeing you online.